Hello, everyone. My name is Ashley, and I am a machine learning program manager at Google.
And I'm Lawrence, and I'm a machine learning developer advocate at Google.
And we are both people of AI.
So join us as we meet some of the most interesting people in the field of machine learning and artificial intelligence.
You will meet leaders, practitioners, amateurs in the field of AI and ML, and how they ended up where they are today, what they have learned along the way, and their outlook on the future.
Sounds exciting. Shall we do it?
Let's jump right in. This podcast is sponsored by Google. Any remarks made by the speakers are their own and are not endorsed by Google. We're thrilled today to welcome Jason Mays. Jason is the public face of WebML at Google. He helps web engineers around the globe take their first steps with machine learning in JavaScript, pushing the boundaries of what's possible in web-based machine learning, which has grown exponentially. He also combines his knowledge of the technical and creative worlds to develop innovative prototypes for Google's largest customers and internal teams, with over 15 years of experience working within web engineering and investigating emerging technologies. Welcome to our podcast, Jason. We're so thrilled to have you.
Thank you so much for having me on the show today. It's great to be here.
And it's great to have you too, Jason. I'm really excited for this.
All right, well, Jason, tell us about yourself.
Sure. So I guess currently I'm looking after web-based machine learning at Google. So that means anything in JavaScript, Node.js, or running in WebAssembly in the browser and beyond. And this is pretty much very fast growing these days. We've gone from 11,000 weeklies to 170,000 weeklies. So it's exciting to be part of that growth. The last time I saw something like this was when the web itself came out. I'm actually that old. And it's very exciting to be at the start of a new industry like this and helping it grow on that side of things too. But before I got into technology, I actually wanted to be a pilot in the Air Force. So I've done quite the round trip to get to this point in my life, I guess, at this point.
Wow, a pilot.
I know, isn't that crazy?
I'd love to ask you to explain in your own words what WebML is.
Yep. So essentially, it's the act of executing a machine learning model within the JavaScript environment. So this is different to Cloud ML, which we've got at Google as well, things like AutoML that run on a server side as a service. WebML is primarily on the front end in the browser, but it can run in Node.js on the server side as well. But it's not the service, it's more the act of running the ML model within the JavaScript ecosystem.
So like when we think about AI as a whole, like we always tend to think, for the people who aren't developers, they tend to think this big, fantastic thing that acts like an intelligent being running in a big data center somewhere, that you can pass it pictures and it'll tell you it's a cat or a dog, or you can pass it language and it can classify that language for you or turn it into a chatbot and all of those kind of things. But WebML is a little bit different, and that's why it's growing really quickly. And where do you really see like how advantageous it's going to be for the end user and for the average person?
Right. Yeah. So if you're executing on the client side in the web browser, you can get some benefits that are really hard to achieve on the server side, or maybe even impossible. So the primary use case for us right now is privacy. None of the webcam data or microphone data is sent to the cloud for inference, which is the act of using the machine learning model. So that means the user's privacy is protected, especially if you're working in healthcare, working with children, or over in Europe with GDPR rules, that kind of thing. It alleviates one headache there. Also, if you don't have a server involved, you've got lower latency. So instead of running at, say, 10 frames per second, some of our models can run at over 150 frames per second in the browser on an NVIDIA 1070 GPU, and that's not even current generation technology. And then the third point is cost, because you're not hiring expensive GPUs to run your service 24/7. You can save a lot of money, maybe tens of thousands of dollars per month. And if you're a startup, that can be a real benefit. And we've seen a number of startups embrace TensorFlow.js in the browser for exactly that reason. Companies like RoboFlow, who make these great ecosystems of data sets and the ability to try models live in the browser. If they were to run that on the server side, they actually told us they couldn't actually run it as a service. It'd be too costly for them.
One of the things I also find like really cool about it is the clues in the name, right? Browser. That like, particularly for mobile, that when you go to an app, in this case, you are browsing to an app, to a URL online, and that app can be updated, that app can be easily, fixed and new features shipped to it, and you're going to get them every time you browse to it. As opposed to if it's encapsulated in a native app, then anytime there's a bug fix, you need to get an update to your app and you need to reinstall it and all of that kind of stuff.
Yeah.
And I think that's one of the really, really cool things about like the ML in the browser part that, can sometimes be very subtle, but I think particularly for somebody who wants to continually ship new updates
Yes.
and to, really innovate, that it makes it super simple.
Yeah, we're seeing a number of creative agencies kind of embrace that aspect of it too. So they've got like real world deployments, maybe digital kiosks in shopping malls. And instead of having to deploy fresh APKs or something to each device, they can just remotely tell the device to refresh the page, and it's got the latest model to run like right there and then. So
Yeah, and also like when you rebuild it in an app, you got to deploy it to the app store, you got to get approvals, that can take time, et cetera, et cetera. So I think that's really
exactly.
cool.
And actually, linked to that point, I'm not sure if anyone saw the new Google AR glasses that were launched at I/O last year, but TensorFlow.js is actually part of that team stack for hardware development too, to accelerate the prototyping. So when you're working on building new hardware, typically you have just a few devices available to you because it's quite costly to make, and they're able to leverage web technologies to get thousands of people to try out the user experience in a way that they could understand and quantify how it's working to improve that, and then only deploy to the test devices when needed for the final stage of the process. So,
And for the people who didn't see those, those glasses are really cool because they give you subtitles in the real world, right? As well as translated subtitles in the real world. So like if I'm sitting in a room with somebody speaking in another language, it'll kind of, show me what they're saying in text. And I think that's really cool.
totally. And I look forward to the day we can have a podcast like this where no matter where you're tuning in from, you're going to hear it in your native language in real time. That'd be very cool. So,
Oh, that would be
yeah.
really cool. Well, speaking of cool examples, what are some of your personal favorite examples that you've seen that the community has put together in using
Yeah.
WebML?
So there are hundreds of great examples I'd love to talk about, but one that particularly comes to mind is based in the healthcare industry. There's a company called Include Health, and essentially they're enabling remote physiotherapy at scale for anyone, anywhere, from the comfort of their house to have a medical grade checkup that's powered by our pose estimation models in the browser. And from that, they can understand the range of motion of the arms and legs and body, and they can track this over time. So in that situation, they've got the deployability of the browser, so they can reach 4 billion people globally if they wanted to. And because of that, they've actually just got a contract with the US Air Force even to kind of test it with those guys. So that's very interesting to see them grow from almost nothing, taking our off-the-shelf MoveNet model and using it in production for a real-world use case that can benefit many, many people.
That's awesome. When you talk about that physiotherapy tool that was built, that seems like it's sort of in my mind, it's like this big company or this big industry that's used your tool to build something that's really impactful. You have a show,
Yes.
right? What's it called?
It's called Made with TensorFlow.js over on YouTube, on the TensorFlow channel. Yeah.
We'll make sure to link it in the notes. And what have you seen from like an individual standpoint as someone who is like, oh yeah, I just want to play around with a tool. Like what cool things have come out from just tinkering around
Sure.
and
Yeah.
playing with the technology?
Yeah, that's a great question. So yeah, we go from all spectrums, from the individuals all the way to the bigger companies. And a great example for an individual would be autoencoders that can dance with you. So there was a lady I interviewed not too long ago, and she has a passion for dance, essentially. And there's these ML models called autoencoders, and she used one of those to generate complementary dance moves, like what pose the partner should be making as she dances in real time. So when she's coming up with a new performance herself, she can get inspiration to show others how to dance with her in that situation. So a very creative use case in that case.
Oh, wow.
Yeah.
So like if she's dancing the salsa, she's got the moves that the partner should be making
To complement that.
virtually
So yeah, it basically you see these two kind of skeletons dancing around
on the screen.
on the screen, exactly. But it's done in real time, so then you can take some inspiration from that maybe, or learn from it, or get some hints of what moves you should be doing. Yeah.
Oh, very cool. Very cool.
Fred Astaire and Gene Rogers eat your heart out.
Yeah.
Wow,
Yeah.
that's really cool. I actually have one of my favorites that came from Jason's show, and it was a very silly demo, but it was very, very cool. And it was like this young lady did a thing with face tracking, and then she would remap her face tracking to the Mona Lisa.
Yeah.
So then as she moved her face around, then the Mona Lisa could move around in the same way and match her. It was spooky and it was really cool all at the same time. No real practical use, but a whole bunch of fun. I almost said a whole bug of fun there, right? But a whole bunch of fun. It was really, really cool.
Bugs are there in there too,
Bugs.
I'm sure.
Yeah. Oh, yeah. It ain't software if there's no bugs.
Yeah, right. So, I keep hearing that there's a lot of fun and there's a lot of creativity in these tools as well. And I want to sort of steer the conversation to kind of asking about why, two questions. Why does this matter? And why do you personally love it so much? Like, why is this a
Right.
passion of yours? And why are you focusing on TensorFlow.js and
Sure.
WebML versus anything else?
I guess to answer this question, I need to tell a bit of a story. So,
Please do.
We
essentially,
love stories.
Yeah, we do. Yep.
excellent. Okay, get tuned in for this one. So, yeah, basically, back in 2015, I was trying to use machine learning to solve a problem that I was tasked with, which was to recognize a Red Bull can. And regular computer vision just wasn't really cutting it, essentially. And if something was similar in nature, it just was misclassifying things. And it turns out that internally we had the TensorFlow product being about to be launched, and people were looking for people to try these things out. And I met a guy called Pete Warden, who's an absolute legend. You go check him out online, a really cool guy.
He
Uh,
focused on TinyML.
exactly, he
Yep,
did all this stuff and was a
he's awesome.
big part of the TF team back in the day as well. And I started talking to these guys, like trying to learn how to do image classification. And I realized it's a really hard problem to solve, even with all this knowledge I had at Google to access. And, my background's computer science, master's of engineering there, and even I was struggling, right? So I took it upon myself to try and make this easier for others to use. So I created something called ZooML, which is actually the first ever incarnation of AutoML, if you will. And essentially, I could upload a video to that service, and within 20 minutes, I'd get an API that I could use to then classify that thing in the future. And that means everyone else on my team who is less technical could actually make these services too. And that's where I realized I really wanted to kind of get into this space where I could help other people to be able to bring their creative ideas to life. And it just so happened that the TensorFlow.js team was looking for someone with a background in web engineering, but a passion for machine learning. And so serendipitously, I kind of joined this team. And now my mission is to kind of bring all those developers online, because there's over 70% of the world's developers use JavaScript. And they're just missing out on all this great playground of fun. And we're now starting to see those people adopt this, and I hope I can get them to bring their creative ideas to life.
I am honored to work on this team with you, Jason, and you, Lawrence. And I find myself, which I'm sure I'm not alone in this, thinking like, how on earth do my colleagues do this? What would you say? I mean, I'd love to hear two things. How you kind of got into this, like 5-year-old Jason. Did he ever think, that he would be where you are today? And secondly, keeping in mind our audience of folks who are like, I'd love to get into AI and WebML, but I'm just too intimidated. What would you say?
Yeah. So 5-year-old Jason would never have even thought this was going to be on my future career path at all. As I said, I was more into flying when I was a young boy. It was only my teenage years when my uncle gave me a laptop. I started getting into coding, and yes,
Take us, if you can, just take us to that moment. What was that moment like?
it was Visual Basic 6. That was the moment. And and essentially, I realized I could get the computer to do something on my behalf. It's like, oh, this is kind of cool. And it got me kind of curious of the types of programs I could make to make things easier, I guess. I've always had that kind of theme in my life of trying to make things easier, tasks that might solve someone's problem or my own problems in a more efficient way. I think that's kind of stayed with me throughout my life, honestly. And typically, if you've got a problem or someone else has a problem, many of us have the same problem. So they tend to kind of scale quite well and get some interest as well, right? So I guess I made like utilities and things that were well adopted by certain people. And that gave me some curiosity to keep going further. And of course, went to uni, did computer science and all that to realize that all the stuff I learned was terrible. And I needed to refine all my coding skills to be proper.
What do you mean it was
Yeah.
terrible?
Well, when you're just learning yourself at the age of 14, you're kind of not using any coding standards. And if you saw my code, it would be very hard to understand and share and, use. I was just working by myself back then as an individual. But as you start to work with teams, you've got to understand, the readability of the code and having it all to be modular and scalable and secure and all this kind of stuff. So that was basically the next 10 years of my learning, refining those skills. And yeah, I was able to do that at various size companies and startups and things, including founding my own. Worked for a semiconductor startup for a while, looking after their web engineering, and wore many hats in that job. And that's where I managed to get kind of a taste for both, not just the programming, but also like design and UX as well, and mixing that all together to create these things that are easy and understandable to use. Because you can make the best back-end system, high-tech thing, but if it's not easy to use by the masses, no one's going to use it, right? So sometimes that can be overlooked, and I try to like merge the creative and tech fields together, essentially. Yeah.
And I think that's always a really great hook when you merge the creative and tech fields,
Mm.
because when you merge the creative and tech side, that creates the hook, right? So that, the people get excited by seeing the Mona Lisa's face moving around or seeing skeletons dancing on the screen and that kind of thing. And they get inspired then by the possibilities. But if we begin by showing, well, here's 20 lines of code that shows you how I optimize this gradient descent algorithm,
Mm.
I think most people will like, some people will get excited by that. But I don't think those are the ones that you want to excite because, they already know your stuff.
Yeah.
And I think that's one of the things that I find particularly intriguing about the WebML area that Jason is really spearheading, because just the sheer creativity and fun aspect of it is it widens access to people to be curious about this and to learn more.
Yeah, totally.
Do you think in order to get to that space of creativity, you need to put a lot of work and back end work to like learn how to code in order to get there? Or, and this is a question for you, Lawrence, as well, because I think based on our conversation last time, you said, and you haven't listened to that episode, tune in, you should go back and listen to it. About how things have gotten much easier to use now. And so it doesn't sound like you do have to put as much work into coding and learning a different language in order to create these really cool things. Is that true?
In general, I believe so. Like even like Jason earlier mentioned, like, his first programming language was Visual Basic 6. And I remember when that came out, but like that would cost you a month's salary to buy the compiler and the tools for Visual Basic 6 if you had a pretty decent career. And that's what the position I was in at that time. And I had to spend almost a month's salary to buy the thing. But nowadays, so many things are free and open source. Documentation is online. You don't have to go to a bookstore and buy a book. And like, that general level of access has been widened. And JavaScript itself as a language is, it has the interpreter in every browser. And, that it's freely available training and freely available courses. And Jason has an excellent course on TensorFlow.js, if you want to take your JavaScript skills to the next level. And that's all stuff that just didn't exist unless you had a really fat wallet, 20, 25 years ago.
Yeah. And essentially that course comes from a distillation of my 3 years of banging my head against a brick wall, trying to understand these things and putting it into a way that I feel that other creatives and web engineers could then understand. So it walks you through the whole process. And by the end, you'll have an appreciation for, a solid 101 in machine learning, and you can be productive with that after that course. So, yeah.
And I think there's something that Jason said there, Ashley, I think is really important, is that, he spent years banging his head against the wall
Right.
for this kind of thing. And I think a lot of people have been doing that, not just here in Google, but in other companies. And that's part of the role of a developer advocate is, we need to develop a very thick skull because we're banging our head against the wall, trying to figure out what's the best way to teach this, what's the best way for people to be able to understand it. And then, when an expert like Jason has gone through that pain on your behalf, it's one of those things that the stuff that comes out of that, then he can then distill into lessons, can really be a shortcut for anybody, not just an expert like Jason, but a shortcut for anybody to not have to go through that pain.
And that's something that in my own personal journey, because I myself am very new to this industry, and I am trying to get to that space, that aha moment where I like see the Mona Lisa. And my first thought is, yeah, that's cool.
Yeah.
But then I'll talk to developers and they are like, this is so cool. And I'm like, okay, it's cool, sure. And I think what I'm understanding about this field is that I'm coming in when everything has been made so easy. And I have missed how hard everyone has had to work and how much in the field of machine learning, people have spent years to try to make things that are now easy. And so there is an added appreciation for when something cool, quote unquote, air quotes, cool comes up, that like for newer generations, it's like, oh yeah, that's cool. But for the folks who spent years banging their heads to make it happen, I myself now am starting to realize how far this technology has come. So it's really helpful to speak to both of you. And that's what I'm excited about with this podcast, is getting to hear how folks, like their journeys that they have come along to contribute to this technology.
Yeah. I guess to put it on context from my side is like, if you go back to my childhood when I first coded a web page, there were no web standards or anything like this. And just making a simple website look the same on every browser was a big pain. And now fast forward to today, not only can we have all that nice user interface stuff going on, but running machine learning models across mobile devices, tablets, laptops, desktops, and it just works. That's a huge advancement since what we had back in the 90s. So, yeah.
And I think that's one of the best like measurements of success, right? The stuff that was hard for experts X years ago is normal today. And if it's normal today, it's going to be easy tomorrow to the extent that anybody can do it. And I think that's really when this magic begins to occur, because one thing about time is that it keeps moving forward. So, today's novices will be tomorrow's experts. And then they're going to be building something that makes them go, wow. And then the next generation beyond them will be like, yeah, it's okay, I suppose. And then they're the ones who are going to be building the next great thing. And like this is generally how things advance. But one of the amazing things that I'm seeing is that they're advancing very quickly. And that just pace of acceleration of it. Like Jason, earlier you were talking about just doing basic computer vision to recognize a soda can. You were an expert, and that's only 7 years ago, and there were lots of other experts, and it was a very, very difficult thing to do.
Yeah.
Now, with a little bit of training, any high school kid or maybe even a middle school kid could whip up a browser, get out Colab, write 10 lines of Python, and be able to create that, that kind of classifier. And it's it's like they need a little bit of training to get there. Of course, it's not like an easy thing, but just the amount of skill needed to be able to have such a payoff is a lot less, and the access to the tools to be able to get that payoff is a lot less. And it's that to me is the most exciting part of this whole thing.
Yeah.
One of my favorite tools that encompasses that is Teachable Machine.
Yeah. Very
also
good.
run on
TensorFlow.js, exactly.
Exactly.
Yeah.
Exactly. Now, since we're on the topic of time and future not looking, I wanted to ask what your thoughts are for the future and sort of what you would like to see. Are there any things that you are excited about, concerned about?
That's a good question. I think I would love to see continued exponential growth of our users with WebML. And I think that we're going to see a whole bunch of use cases that have never even been considered before. Because, there's a lot of creative folk in our kind of cohort of people who use us. And they're going to take a regular machine learning model and use it in a way you never even imagined. And we're going to see a lot of interesting things coming from that. So I'm excited to see all that. And hopefully they'll be on my show in the future. And generally speaking, I'm looking forward to the performance gains we're going to see. So running in the browser used to be a bit of a bottleneck, but now we've got faster and faster performance gains. We're getting more parity with like the server-side level of performance in the browser. So that bottleneck goes away. And, the actual bottleneck these days is the hardware. So as I said, some of our pose estimation models and things run at 150 frames per second plus. Your webcam runs at 30. So your bottleneck is actually your camera at this point. It's not JavaScript or the web. It's actually your hardware. So I'm excited to see how all that evolves and people taking new sensors and things that didn't exist before and combining that into the web ecosystem with technologies like Web Bluetooth Low Energy, Web Serial, Web USB to control hardware, and moving to other platforms like Raspberry Pis and things. We can also run JS on there too. So, yeah.
So one of the things that I'm really curious about Jason's opinion on is like today, like we think about the browser as like this window onto the internet. It's a thing that we open up and we browse, and then we'll get a page rendered to us, and that page may have a model and all of that kind of thing. And, we have that on our desktop. We can also have that on our phone as a smaller device. But with all of that power coming in through those standards and like now the ability to run ML models, as I project forward, I start thinking about, well, where else will compute live? Right? Can my fridge have compute in it, or can my desk have compute in it? And if they do, is like really the engine that was formerly used for browsing, is that the most appropriate one for that? Because of the things we spoke about earlier, like the easier deployability and updatability and all of that kind of thing.
Yeah.
And if that is the case, is that like, in a really excellent area where we could have ML models?
That's a good question. I was actually working with the Nest team in the past, and those home hubs and things are actually web interfaces. So they're running JavaScript, and they were interested in using some of our models and some of those devices in the future too. So I think we'll see some of these like ambient devices around the home actually having like very simple like web servers and things to communicate very efficiently with bidirectional communication and all this kind of stuff to make it easy to communicate with these edge devices. And maybe the ML is done on device, maybe it's done remotely. I was actually trying to brew up a new idea, which is I've dubbed on-network machine learning, which is neither the cloud nor local. So you actually have a kind of like a brain on the local area network with low latency, but then you've got these low-powered devices that can talk to it via the Wi-Fi, and it offloads the compute to that device that's on the local network to get the benefits of privacy without having to rely on the cloud. So you can still work like locally offline, if that makes sense, which is kind of cool. So yeah.
So instead of distributed computing, it's distributed intelligence.
Exactly. That could be interesting to explore. So
Yeah. Well, just to pivot a little bit, I really wanted to come back to this idea of how to get started.
So I'd say stay curious when you're younger and don't be afraid to try things out. If it doesn't work, you shouldn't give up on that. Like I've had many sleepless nights where things don't work, and I just got to take a break, come back to it later and keep trying. I feel that today's generation is very wanting instant gratification, and some things take time to mature in your mind to really appreciate and understand. And but if you put that effort in early on, that will kind of stay with you for your later years as well, and will help you create great things in the future.
Sky's the limit, literally, in your case.
Yeah. While we're on the topic of the sky, I mean, like we spoke about Jason wing walking, but that's not the only crazy superpowered thing he's done, right?
Oh no, I've also tried to fly like Iron Man using a actual real life jet suit. So, there's a company called Gravity. It's called Flight Club instead of Fight Club. So, and basically that was a lot of fun. It's really hard to master though. It's like a 1,000 horsepower, 5 engines strapped to my body, and trying to maintain a hovering state without spinning off out of control with very little friction is quite hard, but a lot of fun. Highly recommend.
I love that they're called gravity because that's the force that drags you back to
right.
Earth. Right? So it was 2 years ago it was wing walking, and then last year I think it was jetpacking, or this year was jetpacking. So what's next year? What are you going to be doing?
What's next?
Will you be our first astronaut, or?
Well, I did sign up to Virgin Galactic as a someone waiting on the list for the price to come down. So not in the immediate future, I think, but there might be an opportunity to go up with the US Air Force in a jet fighter, which would be cool. So that's on my to-do list, and hopefully not too distant future if I pass the medical checks.
Well, I think we'll end with our final question for you, which is, what is your favorite AI movie?
Okay, I'm going to go with a TV series actually that is touching on AI principles, I guess. There's a new series that came out called Devs. And
oh, I love it.
It's based in San Francisco. So that was curious. What's this SF series about? And essentially it touches on the principle of, if you can model everything with extreme accuracy down to like the quantum level, let's say, can you then predict what is most likely to happen from all of those states? So if I suddenly shout at you right now, you're probably going to jump. So the series is basically investigating that whole principle. Like it is therefore everything predictable in a way. And obviously that goes into a whole rabbit hole of free will and all these other things. But, this might even beyond quantum computing to actually even do realistically. We don't even have enough compute to do anything like that right now. But, looking towards the very, very, very future, like if you could model everything, could you then understand things well enough to do that? And I was actually thinking with all these like image generation things that are going on now, like you could have like hallucinations of all the possibilities from a certain point in time if you could narrow down the search space, which I thought was very interesting after seeing that show. And I know it's an interesting topic I sometimes dream about. So yeah.
Well, we heard already that when you dream about something, you wake up and start coding it.
Yeah.
So have you started coding this one?
This one I think is beyond me with current technologies, but I'll keep it on the back burner for now. So
keep it in the subconscious. It'll show up in the dream cycle. Well, thank you so much, Jason, for taking the time to be with us and talk with us and share with us today. It was an honor to have you, and we will make sure to link all of your resources and all of the things that you've mentioned in our podcast. And thank you, Lawrence, my trusty co-host.
As always, thank you, Ashley, for running such an amazing podcast. I can't wait to hear this one.
Same.
Cool. Thank you for having me. Cheers.
Thanks, Jason.
All right, tune in to the next one. See you soon.